Okay. So first of all, welcome to the course. So we're going to start by learning SQL Server. So apart from that, we'll be learning something called as SSIS, which is a tool where we load data into databases. Then we're also going to learn some cloud components. So we'll even see what cloud is and there are many technical words, right? So we're going to learn what they are. We're going to understand what they even mean. And then we're going to go into some of the technologies that are used, that are used to get a job. Obviously, that's the ultimate target. So that said, let's start from the very basics. So database, obviously is the word data, right? In computing, data means any piece of information. It could be text, it can be images, videos, files, right? Word document, Excel document, PDFs, photographs, MP3 files, audio files, video files, whatever, right? So there's a lot of information that is out there. But in business IT, right? When we talk about most of the jobs that people do are business IT focused jobs. I mean, not everyone works for Google or Facebook, right? I mean, we don't work on building UIs, or we don't work on building some sort of photo sharing app or those. The target that we're going to do initially is we're primarily only going to learn how textual data is stored and transferred and transmitted, because that's where most of the action happens. A credit card swipe, it'll require some information. Okay, where did credit card, which vendor was the credit card swiped? How much was it for? What date? What time? Right? What is the remaining amount? Stuff like that. And everything is primarily text based. Even when you do online shopping, when you even watch some video, you search for something, you pay, you make payments using card, and which is textual data. There's no images and there's no audios and videos, right? So most of the business IT in modern business IT infrastructure, or modern IT setups or shops rather, we only work with textual data. So in textual data, we have different types of data, interestingly, and which is simple to understand. So we have numbers, then we have string, right? So within numbers, again, we have integers, then we have decimal. Integer is only 1, 2, 3, 4. Decimal 10.1, the decimal, right? The dot. So anything that we have, those are decimals. And in strings, we can have like regular characters. We can have special characters like star, bracket open, bracket close, apostrophe, full stop, right? These are all special characters. Regular characters, ABC, uppercase, lowercase, numbers. So any English alphabet are the regular characters. So these, and then we have more advanced but important data types like date. Then we have date, we have time, we have time zone. So let's say you're making a purchase in US, somebody's making a purchase in India with your credit card, like maybe you shared it with friends and family. So that way, the swipe happened at India, or maybe it's an online purchase, but not a physical credit card swipe. Right? Your credit card is used. So time zone is also a very important factor. And information can be about an entity wherever, like everywhere in the world. Within US, there are 3 time zones. Let's say you travel from East Coast to West Coast, and you make purchases in West Coast. How will the bank track? How will it know how to even validate those transactions? You're going, like when you go to West Coast, you're going into the past, right? Because East Coast is already ahead of West Coast. So how will the whole thing even work? Like how will you keep track? Let's say somebody purchases from India. Let's say right now somebody is using your card, and they're purchasing something in India, and you're purchasing after that. So the transaction stamp in India will be in the future, right? In India, it's midnight or early hours. Saturday. Right now it's Friday for us. So how can your card be swiped on a Saturday when it's Friday? So these are all the things that we need to factor. These are all really matters a lot in business IT, right? So this piece of information that we see is stored somewhere. Let's talk about database later. So we have we have this kind of information that we need to factor in, that we need to put some calculations, we need to do some validations, and a lot of stuff that goes on. Now you can store this information in a file, right? That's not a problem. So let's see what the problem really is with storing in a file. So let's say I'm putting some data points here. So I'll say, okay, I have $1,000. I'm spending maybe $100 on grocery. Okay, now I'm saving this file. Now let me open this file again from another editor. Right, I'm using Notepad++ as one editor. I'm opening the same file in another editor, and I'll say, okay, here I want to do $200. I'm going to buy, I don't know, some shopping. Okay, now the same piece of information is being changed in two different files. Right. Now, if I save this, and if I go here, it'll say the file has been modified by another program. If I say no, what will happen? So the same information, if it is edited by two different editors, for now, let's call them editors because it's very easy to understand. Same piece of information is being changed by two different editors, right? So which one is true? Which one goes first? Which one goes next? How will we handle this information? What if it's changed by 1,000, editors at the same time? So we need some sort of, we need to go track to the lowest second, right? Lowest millisecond. In fact, sub-second information is what we need. And we need to make sure, okay, the latest one is the final copy that we need. Is the problem statement is clear, right? Any confusion? So the problem statement.
Sorry to interrupt you. Are you sharing anything? I cannot able to see anything. Are you sharing anything?
Yes. Is no one able to see my screen?
We can see the screen.
Okay, so Meenaka, can you please rejoin? I'll pause.
Okay.
Yeah, please
Okay.
exit and rejoin. I'll pause the meeting for a minute. Yeah. Can you see the screen now?
No.
What device are you using?
Laptop.
Okay, yeah, that's weird. Try exiting the Teams, like, close the Teams. Maybe it's a Teams issue. Just exit the Teams, right click on the Teams icon and then end it and then reopen it again.
Okay, sure.
Yeah.
Thank you.
So let me write the problem statement while she's back. So the problem is, so I have some data and this data is being changed by multiple applications, right? So this editor is one application, this editor is one more application. So can you see now?
Sorry, I cannot able to see.
Oh, that's bad. I mean, other people are able to see. You know what? I think it's it could be your networks. Teams does this sometimes. See if anybody else is using and see if you can ask them to not use your network. That will be one way to do it.
Okay.
Or try connecting from another device. That's all I can say.
Okay, I'll try to.
So try connecting from your phone. Like you can listen right now. See if you can connect from your phone or iPad, and you need to install that app, obviously. So that's one way. Yeah. So the problem statement is, We have one piece of data that will be the same piece of data will be changed by multiple applications. So the right technical term is applications, right? So multiple applications are trying to change the same piece of data, but if you put it in a notepad or if you put it in one of these, it's not really going to work because these these pieces of software which are supposed to be editors, even Excel sheet, cannot or will not support something called as multiple or parallel processing or parallel querying, right? They can't open the same piece of information over and over. So you need a specialized software where you have some data and this data can be read by multiple, what we call it as connections. So multiple connections can be made to the same piece of information and it can be changed, it can be read, it can be modified. I mean, it can be added, modified, deleted. Like the three base operations that we can do on any piece of data is we add the information, we modify the information, and we delete the information, right? And obviously we can also read the information, right? So these operations in programming is called as CRUD. CRUD is create, which is add, read data, R is for read, U is for update, D is for delete, right? So we can create data, we can update data, we can delete the data and read the data. So there's a piece of software called as database. Any database that can give you this feature or any software that can give you these features is a database. Also, there's one scientist called as E.F. Codd. So this guy proposed something called as Codd rules. Right. So he said, okay, in a system to be called as a database must be, it should, there should be some sort of consistency within the read, write of the piece of information. There could be parallel access and stuff like that. So all said, any software that adheres to Codd rules and that can support CRUD can be termed as a database. And in modern applications, database is even more sophisticated because they're over the network. They could be on your phone. There could be micro databases on your phone, within an app. There'll be some databases because there's a lot of information, a lot of small, low level information that needs to be constantly read, updated, changed, right? This CRUD operation that you do on any piece of data is pretty constant. Even if you're playing a game, you need to update the score, you need to, change, you need to start billing, an ad needs to pop up at a certain time. All these are calculated and where the information is stored. You need some place to, store this level of information for an app or anything to perform, right? And for every action, you need to store that somewhere. The ideal place is to store it in a database, or there are micro databases as well, which are embedded within your app. Okay. Or your app might talk to a database which is in a remote location. It may be, let's say you're doing online shopping, you're searching for something. So you go to that online retail store, your app actually will read that remote databases data. It will get you, price information. It will get you the image that you're looking for. It will get you availability, description, all the information. They need to be stored somewhere, right? So the place where they store this information is called as a database. Is this clear so far?
Yes.
Yes.
Right.
Yeah, bro.
Yes.
Now, so there are many commercial databases that are out there. Some of them are open source. Open source meaning which is free. Some of them are, commercial, like paid. Right. Obviously, the paid ones are good. Open source definitely is good, but they're not on par with the commercial ones. The top database is Oracle. Then we have SQL Server. Then we have PostgreSQL. MySQL is another popular free database. Then there are cloud databases like Redshift. Then there is Synapse, right? Snowflake. So many new databases, like everyday cockroach database. I don't know. Many databases that are out there. And every database, interestingly, now comes the coding part, right? Because theory is all fine, but the real deal is coding. So every database has three components that everyone needs to understand. The first component that you need to learn technically is called SQL. The second component is TSQL. The third component is additional binaries. So what is SQL? SQL, structured query language, standard query language, is a language which is primarily based on set theory. It's very easy to understand, very simple to learn. It's not really complicated. So you can, let's say I'll give you 10 things, like say 10 marbles, and with different colors. Now, if I tell you pick all blue, pick all green, and of different sizes, pick all medium size, large size. So there are different ways in which you can look at the data, right? So data can be sliced and diced in like different ways. Obviously, the same piece of information could have little variations, and you can, get those piece of information. So the CRUD operations that you do happen in SQL. Okay. Now T-SQL is a programming language. So a programming language is where you have to code, right? I mean, even SQL is coding in a way, but programming language will have, it'll have constructs, it'll have, the two type of general programming languages, you can say one is procedural, one is object oriented, but thankfully we don't have object oriented in T-SQL. It's relatively easier to learn, but nevertheless, it's a coding programming language that you have to learn, right? Because this becomes very mandatory that you understand both of these concepts. The third one is the additional binaries, where you'll have the database will provide with tools, right? Tools to interact with it. Let's say you have to interact with command line. Let's say you have to interact with GUI kind of thing. Let's say you have to do some operation, export, import, take a backup of the database, apply new upgrades, new security patches. There'll be different ways, different things that you need to factor in. All these are additional binaries or additional tools. As you can, binary is nothing but a file, right? So additional tools. Let's talk about binary later. So there are additional tools that you need to learn. Okay. So thankfully, SQL is common for all databases. So if you know SQL, you can pretty much work in any of these databases. It's not really, there'll be a very, very small difference if at all there is. But T-SQL is what is specific to every database. Okay. SQL is generic for all databases. T-SQL is specific for every database. So the T-SQL of Oracle is not the same as the T-SQL of SQL Server. In Oracle, the T-SQL is called as PLSQL. So in here it is called PGPLSQL. This is called T-SQL, right? The programming language that I'm saying. So here this is also called T-SQL. Even this is PGP. Redshift is basically Postgres. Synapse is basically SQL Server. Snowflake is its own, right? So these are all the modern databases, and SQL Server, for our specific thing that we're going to learn, there is a cloud database called as Azure SQL. So even this is also the programming language of this database is also T-SQL. Now, what is cloud? Cloud is nothing but some computing power, some memory, and storage, and some software. So let's say you want to run something. Let's say you want to use Excel on your machine, for example, right? So to run Excel, you need a computer. minimum requirements for Excel, maybe let's assume it's like i3 processor, like 4 GB RAM. And of course, you need the software. You need a licensed Excel software so that you can work with. And then you need a hard disk where you're going to store, right? Wherever you are going to store your information, that is the storage where you want to store your Excel file. Now, what you're doing is on your machine, right? And the problem is not two people can't use your machine at the same time. That's the first problem, right? The second problem is, let's say your Excel is becoming very complicated and it requires a lot of memory for only like 2 or 3 or 4 applications. You have 4 Excel sheets where you have like, data of your entire township or entire colony where you have to manage and you have to give answers. Somebody will ask you some question. It's your job to give the answers, for example. So if your computing power is not going to support it, what do you need to do? Simple answer is you need to upgrade, right? You need to put more computing power. More computing power is only two things. It's only memory and your CPU. Memory is what we call as RAM, right? 8 GB RAM, 16 GB RAM, whatever. That is called memory. Storage is your hard disk, SSD or regular hard drive, external hard drive, whatever it is. So now computing power is i5, i6, whatever. I mean, like AMD, different microprocessors that are out there. What you have is called as on-premises computing power. What cloud does is cloud is elastic, just like a rubber band, right? If you need more computing power, they will automatically add it. If you need more memory, they will automatically add it. The day your application doesn't need that much, they'll decrease it. You can stretch a rubber band and then release it or whatever, right? So it's flexible. They'll give you flexible computing power. That's what any cloud provider does. So the most popular cloud providers obviously is AWS is the top. Then we have Azure. Then we have Google Cloud Platform, right? So these are all the cloud providers, and they'll give you different software that you can buy, you can rent. Even computing power is billed to you by usage. It could be billed every minute. It could be billed every hour. Usually it's billed every minute. How many minutes you use? They'll say, okay, I'll 0.03 cents or 0.1 cent per minute. So every day it accumulates to a certain amount. Every month it accumulates to a certain more amount, right? The more you use, the more it will be billed. So this is how a cloud provider will give you computing power. All you need is your local machine, and you'll use Chrome or one of these browsers to interact with different elements on the cloud, different services or components on the cloud. You will use your browser basically. That's it. It's not really complicated, but you need to know how to use it. There'll be security aspects to it. Let's say, not everyone can access it, right? So you need to secure your content, your software, your data. Then you need to give access to different users. You can't create one user ID and share it with everyone. So maybe your different team members will have different usernames, passwords, and they'll have access to different applications. Some people can only read. Some people can do both read and write, right? So all these capabilities are given to you by a cloud provider. Is this clear?
Yes.
Okay.
Yes.
So what we're going to learn is we're going to learn these three specifically for these two, right? We're going to learn what and how SQL works. We're going to learn T-SQL. We're going to learn some additional tools. Apart from that, we'll also learn an integration tool. So integration means in data, when I'm talking about data, databases and computing, right? Data integration means loading data from a source to a target. A source, what is a source? Source could be a file. It could be a database, right? Or the more advanced stuff. Message queue. It could be an email. It could be a web service. maybe email is not a source, obviously. So these could be your sources. Then targets could be the same. You can have file, DB, message queue, web service, and stuff like that. But we only know what's a file so far. We don't know what these are because I didn't teach you them. Okay. So database, as I said, is a software which will adhere to CORD rules, and then it is going to do CRUD operations. Think of this as a database for now. That will be easy to understand. You can create some information. You can update, delete, and read information. CRUD, right? So a database is something that can do CRUD operations. Message queue web service, we'll talk later. But we will have a conversation. We'll even in the cloud, we'll show you how to use them. It's very easy. In fact, it's not, it may sound intimidating, web services and this, but it's pretty simple. And data integration is loading from here to here. Pick one of these source type, pick one of these target types. While loading, you might have to change the data. Say, for instance, you're loading date data, and then you say, OK, I want to convert the date into GMT or UTC or something like that, right? I want to factor in the time zone and convert it into one time zone. Let's say all transactions equated to Eastern time zone or Central time zone. That's some level of transformation. Or let's say if I give you bill information with bill details, you could say, no, I don't want the bill details. I want the bill total. So you're changing the data, right? So data integration will involve those aspects, either getting the data as it is or changing the data and loading it into the target. So SSIS is one of the tools which will help you with that. SQL Server Integration Services, that's what it stands for. Any questions? Right. Okay, so theory is done. Let's start coding. So for the software that we're going to use, I already have a Docker. I'll tell you what a Docker is later if you do not know already. Then I'm going to use an IDE, an integrated development environment. So SQL Server gives you one tool, but I'm not going to use that. Rather, I prefer using this. So here I have a database already. So I have some schemas. So I'll open a sheet on this schema. So we'll talk about all these words. What's a schema? What's a database? It's all, so this is called this is your SQL Server, right? The software that is running. The SQL Server software that is running on a machine is called an instance. Okay? So in SQL Server, so we have an instance. In an instance, you will have a database. In a database, you'll have a schema. In a schema, you'll have a table. In a table, you'll have the data. So to access the data, you'll go through these many hoops. But when you're coding, when you're actually working, you'll directly be in a schema. Okay. So data is actually in a table. So table is very easy to understand. Let's come back to some more basics. Now I think this will be super easy from here because it's all coding, right? I'm just going to create one Excel sheet and then we're going to talk about certain things. So you see an Excel, right? You all can see my screen?
Yes.
Okay. In an Excel sheet, this is called a column. The vertical one is called a column, right? This is called as a row, the horizontal one, which spans across columns. Okay. So this is called a table, a tabular data structure. So a table where you can store some data. So a table has columns and rows. Okay. Now let's look at a practical use of a table. Let's say I create an employee table. In this table, I have employee name. Then I have salary, maybe an employee ID, right? So I'll move that here. There's the name of the table. There are these three fields. Then I'll have another table called department. Then here I'll say department ID and department name. Now let's say I have employee ID 1, 2, 3. Good enough. A and B and C. Then I'll say, okay, this guy gets 1,000, 2,000, 3,000. Now I have department 1 and department 2. Department 1 is say IT and this is sales. Okay. Now I'll create the department column here. Then I'm going to say this is 1, 1 and 2. Okay. Now, is it visible?
Yes.
Okay. Now, can you tell me the name of the department to which employee A belongs to?
IT.
How did you tell me that?
The department ID common. I mean, like in
These two are
first table,
common, right?
department ID is 1, and
Yeah.
the 1 belongs to IT in
Right.
second table.
So you're actually what you did is called a join operation. Okay. So this is called a SQL join. SQL works like this. It's pretty simple. It's not really difficult. Now, what is the maximum salary? What is the name of the employee who gets the maximum salary?
C.
It's C, right?
Yeah.
3,000 C. So you can visualize, you can see the data in any which way. You can see it from a salary perspective. Let's say, what is the name of the employee who works for sales? So you can again track back like this and you can say it is C. Right? So the data can be visualized in any way. Any question can be asked. Any information can be retrieved. So the question that you ask is the read, right? In CRUD. Any question that you ask is read. Any modifications, let's say I'm going to update the salary for this person to 2,500. That's an update. You're changing the data. Right? Let's say I'm going to remove this employee, or maybe I'll add one employee and remove them. So that is deleting the data. I'll add department ID 3 and say admin. Then I can remove it. That's deleting the data. Right? Creating is adding a new row. Modifying a existing column of a row. You modify a column of a row or all the columns of a row. When you add a row, you're adding across the columns, obviously. You can add, delete, and read. And this, the other aspect of a table is every column has some properties. The first property is the data type. What is the data type of EMP ID? Please use the information only that I taught you. You don't need to think of anything else. In here, what data type is EMP ID?
Integer.
It's an integer. So if I put salary is decimal, right? Now that becomes decimal, right? It's not showing up. I think I need to type something. So salary is decimal, right? So every column, the first property of every column is a name, obviously, right? So every table, when you talk of data, when you talk of table, a table will have columns and rows, right? So let's talk of columns first. A column will have a name, obviously, it'll have a data type, right? Now, Let's figure out something else about columns, something more interesting about columns. Now, if there's another employee A, what should I do? Should I also give that person employee ID 1? I should give some
No.
other number, right? Maybe 4.
Yeah.
4 is good because there's a sequence, right? So this A might get 2000, right? And this person may belong to department 2. So the row, the column, these are the actual columns. These are the actual piece of data that is important. But to identify each row, you need one more column which will identify each row, right? This will employee ID 1 means it is A with this salary with this department, right? That's how you differentiate every person. Let's say we're talking business here, right? So to identify this one particular person, you're giving an ID called 1. Here you're giving an ID called 4. What's so special about these IDs? Are they repeating?
No.
They're unique, right? They are not repeating and they are unique. So you can put a rule saying that, okay, some columns can have an attribute of it has to be unique. I'll set this rule. The right programming word for the rule is called a constraint, right? The first constraint that you see is called primary key constraint. So primary key, when you apply a primary key constraint on a column, you may apply, you may not apply, right? You may have it on all columns, 1 column, 2 columns, doesn't matter. When I say this column, the values of these columns should be unique. They cannot repeat. You cannot put in 1 again. If you try to insert a 1, if you're trying to create a row, when you create the data in CRUD, let's place the CRUD here. In this table, when you say, okay, I'm saying in table employee column EMP ID is primary key. When I set that rule, if you try to insert 1 again, it will throw an error. Database will throw an error saying that primary key violation occurred and we cannot accept this data. Database will not accept that data when you're trying to create that data. Even if you want to update 4 to 1, right? If you want to change, if you want to, that's also a violation. Even that will fail. Make sense?
Yes.
Okay. Now let's look at another constraint. Now, what is 1? 1 is IT, right? So even this is a primary key, right? Ideally, you need to make that a primary key to uniquely identify a department name. Make sense?
Yes.
Now this referring is called as foreign key. It's also a rule. Constraint means a rule, right? So let's understand a particular feature of foreign key. It's pretty obvious. Foreign key means I'm going to create this as foreign key. I'll say the rule is in employee table, the department ID column is a foreign key where it is referring to department tables, department ID. Make sense? Employee tables, department ID is a foreign key. Department tables, department ID is a primary key. So in foreign key, you can have duplicates. The values can be repeated, but in primary key, it should not be repeated. Also, a foreign key must only look up a primary key. What happens if I put 2 here? Now tell me, what is the department employee 4? What is the name of the department that employee 4 belongs to? Can you guaranteely tell me which one? he or she belongs to?
No, we can't say.
You cannot, right? Because if this is repeating here, how will you validate it? You can't resolve that issue. So the rule is, if you say this is foreign key, this will refer to another table's primary key. It must. That's one of the chord rule. Remember this guy? Make sense?
So I have a question. So
Mhm.
if you make a department ID as a primary key in the department table,
Mhm.
you can't put like another two, right?
No, I cannot. I'm just demonstrating. You're right. I should not.
Okay.
All I'm saying
Okay.
is if primary key doesn't, I'm telling you why a foreign key should look up to a primary key.
Okay.
It
Yeah.
must. I mean, there's no other option. It must. A foreign key must look up to a primary key in another table. It cannot look up to a regular column. A non-constrained column lookup is not possible. The reason it has to look up to a primary key in another table is because you cannot resolve it uniquely. That's the issue. Make sense?
Yes. Yeah. Understood.
So here the way we write in pictorial or in textual format is we'll say this is PK, primary key, the acronym that we usually use. So this column is FK, which is foreign key, right? And then here we're going to say this is the primary key here. These are the only constraints. Again, these are the features of a column, right? So a column definitely, these are mandatory. It has to have a name and a data type. These two are optional. There is no constraint on ename, right? The only rule is ename should be a string. And salary, the only rule is salary should be a decimal. Beyond that, it doesn't matter what decimal you put there. Make sense?
Yes.
Yes.
You can also put a check constraint. Another constraint is called as a check constraint. Check constraint is simple constraints which do not enforce any, particular references or uniqueness, but you can say, okay, salary cannot be less than 500 or 1000. Let's say the minimum is this, because you need to pay minimum wage, you need to comply with federal rules. Let's say the minimum salary is this. You can put a rule saying that salary should be greater than some number. If you try to create in CRUD operation, if you try to create data on this column which violates the check constraint, it will throw an error. Database will throw an error saying that I cannot accept that data. Make sense?
Yes.
So this is how we represent information. Is already 7:20. Okay, so these are the basics, right? So what we'll do going forward is I'll show you how we're going to create tables. We're going to write syntax, in fact, directly to create the tables. Then we'll understand how joins work. I mean, I just showed you here, but I'll show you the logic behind, how it actually works. So that way it'll be imprinted in your brain forever that, you'll know how to write a join, no matter how complicated the problem is. Then we will be looking at different variations within join. We'll ask, weird questions, and then, we'll get answers for those. There'll be a lot of assignments, obviously, and there'll be content that you can access for free. We have a GitHub profile, which has a bunch of these things. So I'll show you all content is freely available online on our GitHub profile. So there's nothing this is not behind a paywall, obviously. So we're still putting new content, but there's some content here. So you can, I don't know, there's some SQL Server tables that you can use, and there's already data for you to use to write queries and stuff like that. So this folder will be updated. We didn't upload the latest content yet. So the objective will be, we will give you a script to install databases. You don't need to do anything manually. A script will be given to you that will download, install. It doesn't matter if you're using a Mac or a Windows, it will work. And once the database is installed, then we're going to ask it, the script will also install the application software where you'll have to interact with the database, because you'll use this editor. This is not a database. This is the editor to connect to the database. Database is like a program that is running in memory, right? To connect to that, we'll use one editor. And this editor dbeaver is going to connect to the database. Then in here, we'll show you how to navigate to that particular instance, DB and schema, and you're going to open something called as a worksheet. And here you're going to write the code, and the play button there is going to execute the code, right? So we'll start off with very simple scenarios. We'll look at a very rudimentary, what we call as a data model. We'll talk about employee and stuff like that. And from there, we'll go to very advanced stuff like retail industry. We'll look at a banking industry. We'll take some specific problems in one of those or both of those, and then we're going to create some problems. And for those problems, we'll try to find database specific solutions like creating tables, creating data. How will you manage the data? How will you give role-based access to data? Like, one person can only be an administrator whose job is only to look at the reports and data, right? A developer or some transaction systems will keep on adding and modifying the data. So there'll be different entities which will be working with this, data set, and we'll try to design interfaces or connect mechanisms to connect and work with all these features from all perspectives. Okay. So it will be an example driven thing, and primarily everything is coding. So the only thing that you ever hear from me is in the intro class. Beyond that, we'll only code. Any questions?
So do we have to install any tool?
You don't need to. We'll give you a script.
demonstration? Okay.
We will give you a script, and the script is going to install everything for you.
Okay.
Okay. And we'll tell you even how that works. Of course, you'll learn it at a later time. When you get into deployment, by then you'll figure it out. It's not really difficult.
Okay.
We're going to use the software that you're going to install on your machine is license free. You're not going to violate anything. And when we give you cloud accounts, that again, we are paying for the cloud, so that you don't need to bother about the cloud. It's just like accessing something like this. That's it. Except we'll give what we have. What we call this is connection information, right? How do we connect to? So we need to put what is the host name, database name, a lot of things. We'll explain all these things. When we give a cloud account, we'll just give you these details. Instead of connecting to the database on your machine, it will connect to the database on the cloud. Okay. All right. Any questions? So we are going to have the sessions only on weekdays. So this is like an intro session just to, test the warm waters. That's it. So beyond that, we will have the session at 6:30 Eastern time every day, every weekday rather. And the session will be around 45 days, 45 sessions. Session will last about an hour to hour and a half, depending on how we are moving. And there will be days where I could be busy, or another instructor who will be helping with me, even he could be busy. We will reschedule the session to another day, or we will come to a mutual understanding and see if everyone is available on a weekend, and we'll try to cover that over the weekend. All sessions will be recorded. Your assignments, your code, your access and doubts will be clarified. You can feel free to always stop me and ask me a question. The objective of this course is to learn. The objective is not to complete a course, right? We're not here to cover some syllabus. The objective here is to learn so that you'll get a job. So we will be learning only in that perspective. And the understanding is you do not know anything about coding or programming. If you already do, that's a bonus. Okay. All right. So